Today we're going to continue learning about right-angled triangles by talking about the sine, cosine, and tangent ratios. So if you're trying to find a missing side in a right-angled triangle, one of the ways to do it is using Pythagorean theorem. But Pythagorean theorem only works if you know two of the sides and are trying to find one of the third sides. So if you don't have that information and instead they give you one of the angles, like these questions down here, we can't use Pythagorean theorem anymore. So what we can use instead are the sine, cosine, and tangent ratios. Now you should have learned about these in grade 10, but there's a good chance that you might not remember, so that's why we're going over it. So sine, cosine, and tangent are ratios or a comparison of side lengths. So if you have a triangle that has a 30-degree angle, right, the ratio between certain sides will be the same no matter whether it's a big triangle or a little triangle, as long as that angle is still 30 degrees. So sine, cosine, and tangent are just different ratios of sides in our triangle. So first thing we're going to do is talk about the names of the sides. And whenever you're naming your sides, we always start, just like with Pythagorean theorem, with the hypotenuse. So across from the 90-degree angle, the longest side is called the hypotenuse. Okay, now the other two sides are named according to their relationship to the angle in the question. So here I have the angle just marked A. So the side that is across from A, so on the opposite side over here, is called the opposite. It is opposite because it is opposite or across from the angle that you know in the question. And then the third side is called the adjacent. Adjacent means beside something. So it's the side beside the angle. Now technically hypotenuse is also adjacent to the angle, it's also beside it, but it's the longest side and has its own name. So I always start by finding the side across from the 90, the longest side, that's my hypotenuse. Then I figure out where the angle is in the question that I know, and it'll change from question to question. Sometimes you might know the angle up here, sometimes you might know the angle down here. And we label the one across from that the opposite, and then the one beside that is the adjacent. So the ratio of sine is opposite over hypotenuse. The ratio for cosine is adjacent over hypotenuse. And our last one, tan, is the ratio of the opposite side divided by the adjacent side. And that seems like a lot to remember, and it is, but there is a little word that we can use to help us. So if I look at the first letter of all of these things, I have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So the word that I use to help me out is spelled using those letters. So I have S-O-H, C-A-H, and then T-O-A. And that is the word SOHCAHTOA. Doesn't actually mean anything, it's just a short form to help us remember. But I use SOHCAHTOA all the time to help me remember my sine, cos, and tan ratios and how they work. So we are going to take a look at an example that we're going to do together. You do need a scientific calculator to do this. And I do just want to point out that your calculator needs to be in degrees. So it's a little hard to tell on this one, but up here in the top, it has DEG to show that it's in degrees. Some calculators might just have a letter D. If it says RAD or GRAD or an D, sorry, or an R or a G, that's not good. That means you're not in the right mode. You want to make sure that you are in degrees. And if you're not in degrees, you can try resetting your calculator. If you don't have a reset button, you might have a button that says DRG on it, which this one does. It says DRG here. Otherwise, you might have to do it with your mode. So if you have a calculator and you are not sure, you can take a picture of it, and then if you email it to me, I will try to get back to you with how you can switch into degrees. Okay, so I'm in degrees, so I'm good. So we're going to try our first example. So it says solve for x. I have a right angle triangle, and I've got a label of x. I've got a label of 130 centimeters and an angle that says 40 degrees. So from here, I'm not going to use Pythagorean theorem because I only know one side, right? If I want to use Pythagorean theorem, I need to know at least two sides. So I'm going to try using sine, cos, and tan ratios. So the first thing you should do is label. So I'm going to start with that hypotenuse. So across from the 90-degree angle, the longest side here is my hypotenuse. Now I'm not going to write out the whole word. I usually just write HYP, or sometimes I just write H, just something to mark that I know that that's the hypotenuse. And then I need to find my angle. So the angle we have is 40 degrees. Across from that 40-degree angle is where the opposite is. And then the third side, the one that's left over that's beside this one, is the adjacent. So of my three sides, I'm going to look at which side do I not know anything about or really need to find. So if I look at my diagram, I notice that we have that the hypotenuse is 130, so I have a measurement there. I notice that the adjacent has an x, so that's what I'm trying to find. And then my opposite doesn't have any markings. It doesn't have a measurement, it doesn't have a variable. So this is the side that I'm not going to use in this question because I don't know anything about it, and I kind of don't care. So what I want to do is then just focus on hypotenuse and adjacent. So if I look at my SOHCAHTOA, I'm looking for something with an H and an A. So this is O and H. Here we go. It's A and H is cosine. So I'm going to use the cosine ratio. So I'm going to start by writing that cosine of A is adjacent over hypotenuse, right? So it's CAH. The A goes on the top, the H goes on the bottom. And then I'm going to substitute in what I know. So cosine of my angle is 40 degrees. Now, you don't have to use the bracket. Some calculators require it. Some calculators don't. So if you don't want to put the bracket in, you don't have to. The adjacent in my picture is x, and my hypotenuse is 130. Okay, so what I need to do is find a way to solve for x. So what I'm going to do is I'm going to say this cosine of 40 is secretly over 1. And I am going to cross multiply to get that 130 to the other side. So I'm going to have cosine of 40 times 130. So I get 130 times cosine of 40. And then on the other side, I do 1 times x, which equals x. If you don't want to cross multiply, you can just think about it that in order to cancel out a divide by 130, we are multiplying by 130. So from here, x is now all by itself, so I am going to multiply this out. So on my calculator, I'm going to do 130 times cosine of 40. So it depends on the kind of calculator you have, what you're going to do. And unfortunately, this is the only calculator I have here with me. Normally at school, I have a bunch of different ones, and I could show you different buttons, but I only have this one with me at home. So if you have a calculator, when you press the word sine, you actually see the word sine on your screen. You would just type this in exactly as you see it. You would do 130 times cosine 40 equals. That's all you have to do. But on my calculator, when I press sine, cos, and tan, I don't actually see the words show up. So I have to do 130 times, and then I do 40, and then I press the cosine button, and then equals. So because my calculator, I don't see the words sine, cos, and tan show up, I have to put the angle in first. So I did 130 times 40, then I hit cosine, and then I hit equals. If you see the word cosine on your screen, you just do 130 times cosine, and then 40 equals. That's all you have to do. And I got 99.5857. So I really want 2 decimal places, which would be 0.58. This next number is a 5, so that's going to round that up to 0.59. So it's 99.59, and this is in centimeters, is the length of my missing side. Draw a nice little box around that. And if you want to see us do the next example, you can join me in the next video.